Hello everyone, my name is Guillermo López-García and I work as a PhD student at the ICB-Lab, the Computational Intelligence and Biomedicine Research Group at the University of Málaga, Spain. I'm here to present our contribution to the CANTEMIST 2020 shared task. Specifically, we have exclusively participated in the CANTEMIST-CODING subtask. We tackled the challenge using a fully machine learning based approach. In particular, we used BERT language model. In this way, we treated the CANTEMIST coding task as a multi-label text classification problem, and we used an output classification layer of multiple sigmoid units on top of the C token representation generated by BERT. The main problem we faced was that BERT can only process a sequence of subtokens with a maximum size n, with n equals 512. However, most of the clinical documents present in the CANTEMIST corpus have a subtoken sequence size clearly above the maximum length supported by BERT. To overcome this limitation, we developed an improved version of our fragment-based classification approach initially developed for the CODIESP shared task. So in the next slides, I'm going to illustrate our fragment-based classification strategy using a clinical document from the CANTEMIST corpus as an example. So firstly, we split the text into sentences. Then we applied the word piece tokenization, producing a sequence of subtokens for each sentence. Later on, we grouped the sentences together, forming short fragments of text compatible with BERT. After that, during the second step of our strategy, in order to annotate each generated fragment, we used the information available for the CANTEMIST named entity normalization subtask. In this subtask, codes annotations include the reference in the text that explains the coding assignment. In this way, using the previously described information, we managed to annotate each fragment exclusively with the ICD-O codes whose text references were contained within the limits of the fragment. Using the annotated short fragments of text, the BERT model was fine-tuned on a multi-label fragment classification task. Hence, at prediction time, given a text fragment as input data, the model produces the probability of each code to be present within the input fragment. However, CANTEMIST coding task is a document classification problem, and the evaluation of the participating systems was performed at document level. For this reason, the last step of our developed approach consisted in applying a maximum probability criterion to obtain the code's probabilities at document level. In this way, for each code, we simply selected the maximum probability predicted by the model across all fragments in a single document. To conclude, we now summarize the results obtained by our team in the CANTEMIST coding subtask. We submitted 5 different ranks of our system. The first 3 ranks correspond to the multilingual BERT model, and the last 2 ranks correspond to the BERT Cielo model. In order to adapt BERT to the Spanish clinical domain, we further pre-trained both models on a private corpus of 31,000 oncology documents in Spanish, which correspond to, respectively, the 2nd and the 5th ranks. In addition, we also further pre-trained the multilingual BERT model on a bilingual clinical corpus, comprising the 31,000 oncology documents in Spanish and the 57,000 discharge summaries and English, extracted from the mimic dataset. This corresponds to the third run. As we can see, considering the mean average position official evaluation metric of the task, the multilingual BERT clearly outperforms the BERT Fiello, achieving our best performance score of 0.847. So that's the end of the presentation. Thank you very much for your attention.